All right, so we're still moving and shaking here in section 4.5. So next up is an example that we've seen some similar ones a long time ago, way back in, let's see, I think it was chapter 2, way back then. So it's been a while. So we're going to solve here for x. Oops, sorry, I'm struggling. So this is e to the 2x plus 5e to the x minus 36 equals 0. So I have something equals 0. Now this is supposed to look quadratic-like. Quadratic-like. And the reason we saw this way back in chapter 2 was the fact that we did this thing called substitution. Now, if I rewrite my little equation here, maybe this will help. So I have something squared plus 5 times that same thing minus 36 equals 0. So what I'm going to do is I'm going to substitute these two pieces, and I'm going to set e to the x equal to, say, I guess a. Just some variable. So now when I replace it, I have a squared plus 5a minus 36 equals 0. So now I do have a quadratic, and I can, of course, factor or use the quadratic formula. Let's see, hopefully I can factor. Let's see, I have 6 and 6. 36 divided by 12, 36 divided by, 9 and 4. All right, there we go. So I have a plus 9 times a minus 4 equals 0. So a equals negative 9 and a equals 4. Now, again, I started with my variable was x, so I need to end with my variable being x and not some other letter. So now I need to do my resubstitution. And so now I have e to the x equals negative 9 and e to the x equals 4. So now, remember we talked about making good choices when we take the log of both sides. In this case, I'll take the ln. So I have ln of e to the x equals ln of negative 9. And then I have ln of e to the x equals ln of 4. So now when I have ln of e to the x, remember my answer is I'm just left with my exponents. So I get x equals ln of negative 9, and then x equals ln of 4. Now, let's look at x equals ln of negative 9. Remember when we talked about the domain of logarithms, we can never take the log of negative numbers or 0. So what that means is that ln of negative 9 is not an answer. I cannot include that in my final answer. But x equals ln of 4 is totally good, and then we could, of course, approximate that, and we would get 1.386 is our approximate answer. Okay, and if you try to put ln of negative 9 in your calculator, of course, you would get domain error. Okay. All right. So now what we're going to do is, of course, we're going to solve logarithms. Okay, so now we're going to be using the same property. If I have log of a same base equal to log of a same base, then I can just set their insides equal to each other. So let's look at some examples here. So I have log base 2 of 3x minus 4 equals log base 2 of x plus 2. So since they're the same log base, and I just have one log equal to one other log, now I can set the insides equal to each other and solve for x. So I get 3x minus 4 equals x plus 2. And again, it's that same one-to-one property that I got with my exponential. So I get 3x equals x plus 6. So then I subtract x. So I get 2x equals 6 and x equals 3. Now, the other thing I have to do with logarithms is I have to check my answer, because I need to make sure that if I plug in my answer back into my log, then I'm not getting the log of a negative number or log of 0. Okay, so really be careful and check your answers. So let's do our check here. Ooh, sorry. So I have log 2 of 3 times 3 minus 4. So I get log base 2 of 5. So that one's good. And then I have log base 2 of 3 plus 2, which is log base 2 of 5. So those worked out. So I checked off x equals 3. Okay. Let's look at another example here. So that was part A. Here's part B. So now I have ln of x minus 4 equals ln of x minus 6 minus ln of x. Now, in this case, they all have the same base, but remember I want one log equal to one other log. So now over here I have to do a little simplification. So first I have to remember, what does a subtraction time between two logs represent? That tells me that is my quotient property. Okay, so now I have ln of x minus 4 equals ln of x minus 6. Oh gosh, oh, x was struggling. Divided by x. Okay, and now that I just have one log equal to one other log, now I can take their insides and set them equal to each other. Okay, so now I just have to solve for x. So I'm going to times x. Going to times x, so I get x squared minus 4x equals x minus 6, because those guys cancel. So now I have quadratic things happening, so I also want a quadratic equal to 0, so I'm going to subtract my x and add my 6 to the other side here, so I get x squared minus 5x plus 6 equal to 0. Now, I have to factor. I think I can do that here. So I get x minus 6 times x plus 1. Of course, please use the quadratic if you need to. So I get x equals 6 and x equals negative 1. Now again, here's where I have to check. I need to check back into the original equation. I need to make sure that if I plug in these answers that I'm good with that. I am not taking the log of a negative number, or I'm not taking the log of 0. So if I plug in negative 1, well, I get ln of x. And so ln of negative 1, I know this guy is out the door. Now let's look at 6. If I plug in 6 into my first one, I get ln of 6 minus 4, which is 2, so that one checks out. Then if I plug in over here, I get ln of 6 minus 6, which is ln of 0. Again, I know I can't do that, so both answers are out. Well, of course you're like, well, Michelle, what the heck does that mean? That means that there is no solution to this little log equation. And that's okay. I don't always have to have a solution. That's just kind of how it goes sometimes. But this is why we have to check our work. Okay. All right. Let's look at some other ones. Example C. Now I have 4 times log base 3 of 2t minus 7 equals 8. Well, here, again, I want to get log equals something else. So let's get log all by itself. So first I'm going to divide by 4. So I have log base 3 of 2t minus 7 equals 2. Now this is just as quick as you think. All I need to do is rewrite it as an exponential. So I rewrite and I get 3 squared equals 2t minus 7. So I get 9 equals 2t minus 7. I'm going to add my 7. So I get 14 equals 2t, so t is equal to 7. And if I plug that in, I get 14 minus 7, which is 7, so I know I'm taking the log of a positive number, which is what I need to do. Okay. let's do another one. Oops. So this would be D here. So now I have a log of W plus 47 equals 2.6. Now this one doesn't have a base written down. Remember, if it doesn't have a base, I know it's base 10. So I get 10 to the 2.6 equals W plus 47. Then I have to subtract 47, subtract 47. So I get W equals 10 to the 2.6 minus 47, which equals, let's see, 2.6. I can't type into my calculator. And so I get an approximate answer of 351.11. And if I plug that back in, I know that I will get a positive number. So I'm going to have my exact answer and my real answer here. All right, let's look at one more here for this little video. What was that letter? I already forget. Gosh, D. Okay. So here's E. Now, if I have log base 2 of x equals 3 minus log base 2 of x minus 2. Oops. So again, I have kind of two options here. I want log equals log, or I want log equals number. So in this case, what I need to do is, actually, if I move the 3 over, that's not going to help. So what I need to do is I really need to actually combine my logarithms. So I'm going to add log base 2 of x minus 2 to the other side. So now I have log base 2 of x plus log base 2 of x minus 2 equals 3. So now I have two logs added together, so I can use my product property and multiply their insides together. So now when I do my rewrite as an exponential function, I have 2 to the third equals x times x minus 2. So that way I get 8 equals x squared minus 2x. Oh, look, our old friend, the quadratic. So I always want a quadratic equal to 0, so I get x squared minus 2x minus 8. So I get, let's see, x minus 4 times x plus 2. So then I have x equals negative 2 and x equals 4. Now again, I have to check. And so which one of these can I not plug in? Remember, go back to the original that's written on my paper. If I plug in negative 2, I'll get log base 2 of negative 2, which I can't have. And always, of course, don't forget to check the other one, because sometimes they both won't work. But in this case, if I plug in 4, I'll get log base 2 of 4 and log base 2 of positive 2. So in this case, one answer works out, one doesn't, and that's okay. Alright, if you have any questions over what we've covered in this video, please come see me in the Math Hub or send me a little email and I'll be happy to help you however I can. If not, move on to our last video.